Hi and welcome to Maths class. In this video we're looking again at solving problems involving the normal distribution, and we're using transformations to the standard to z values in order to solve those problems. And we're doing one more worked example, and in this example we need to find both the mean and the standard deviation. So let's look at the example first of all. It's quite long, so I might need to just shift things around to make room for me to finish it, to do all my working. But we'll just start with the first one, A. The weights of Australian rules footballs are normally distributed. It is found that 20% of the balls weigh less than 418 grams, while 7.5% weigh more than 437 grams. Now, this is a multi-part question, so it's really important that I define my variables here. So, first of all, let's write down, let's use W for weight. Let W be the weight of an Australian rules football in grams. So I know that W is normally distributed, but I don't know either the mean or the standard deviation. Oops, I need a little in there, normally distributed. So what I'm going to do is I'm going to use the information that I've got in a similar way to how we did in a previous example, but this time I'm going to have two unknowns in each equation. So of course what that's going to set up is a set of simultaneous equations. Now if you think you know what to do, what you should do is pause it now and have a go and then hit play and watch the way I do it. So the first bit of information I write down is I know that the probability, can you see that? Only just, the probability that the weight is less than 418 is, well, 20% of the balls have a weight less than 418, so that equals 0.2. And I know that the probability that the weight is more than 437, that's here, happens in 7.5% of balls, so the probability is 0.075. Okay, so now what I need to do is grab my CAS. Oh no, not yet. One more step. Now I need to convert those into Z values. So let's rewrite this one, the probability that Z is less than, and remember I'm using this equation, Z equals X minus mu over sigma, where mu is the mean and sigma is the standard deviation. So now my X in this case is my W. So it's 418. So I've got 418 minus the mean, which I don't know, over the standard deviation, which I also don't know. But this still equals 0.2. And while we're at it, let's jot down the information for this one before we start grabbing our CAS. The probability that Z is greater than, same thing, 437. I subtract the mean and I divide by the standard deviation. So I've now converted this into a Z value, which is why I can use the standard normal now, which is why I can now grab my calculator and work out what values on the standard normal horizontal axis give me these probabilities, 0.075 and 0.2. But remembering that this is less than and this one is greater than, so it's going to have a right tail. So let's go to CAS. There's my friendly CAS. All right, so the first thing I want to do is I go into my distribution. I'm doing inverse again because I've got my probabilities and it's a normal. And for this left one, it's going to be a left tail and my probability is 0.2. So I put that in and I don't change anything else because I'm in, this is a standard value now. So I hit OK and I get negative 0.8416. Now it's going to be a little bit trickier to do what I did previously and use my answers in CAS. I'm not going to be able to do that. So I've got 418 minus mu divided by sigma now equals, what was it? Negative 0.8416. Negative 0.8416. Now, this question doesn't say how many decimal places I'm going to. So what I'm going to do is I'll go to 3 in my final answer. Sorry, that should be a 6, shouldn't it? Yes. I'm going to go to 3 in my final answer, so I'll go to 4 for now. Similarly here, I'm going to have 437 minus mu over sigma equals, and I need to calculate that. So I go to interactive, distribution, inverse normal. Now this one, remember we said had a right tail because it's greater than, not less than. And my probability is 0.075. Enter that. And I get a value of 1.4395. So let's jot that down. 1.4395. Now I'm running out of space here, so what I'm just going to do is shift everything up. We don't need to keep looking at the question because we know the question just asks for the mean and standard deviation. Can we see everything now? Not quite. A little bit higher. And maybe if I shift CAS down a little, that will help. Okay. Not too much because you need to see what I'm doing in my CAS. All right, so basically what I'm going to do now is I'm going to enter these as simultaneous equations. So actually what I'll do is just pause. Okay, so now you can see what I've done there. I've put in those 2 equations into my CAS. I've actually done a copy and paste of the answers rather than rounding off. I'm probably being super fussy. I think going to 4 decimal places would have been just fine. What I haven't done in there is, I should point out, I've used X for mu and I've used Y for sigma. And then here I just need to point out to my calculator that X and Y are what I'm looking to find. And look at that. My value for X is 425. It's pretty close to 425. I'm going to stop there at 425. I think that's reasonable. And Y, I'll go to 3 decimal places, 8.329. So let's just jot that down. Actually, given that we're dealing with grams whilst I was writing that, I thought, no, I'm not going to write 8.329. I think 8.3 grams is accurate enough for measuring footballs. So I've got 425 is my mean value and 8.3 is my standard deviation. So I just want to point out to you what I've shown in my working. I defined W. That's really important to do. And I pointed out that W is normally distributed. Oh, and I made a mistake there. That should say sigma squared. Then I wrote my 2 probabilities here. So that was the information given to me in the question. I transformed those into Z values. And then I wrote down 2 equations. This is equation 1 and this is equation 2. And then I solved those simultaneously. I don't need to show any working for the solution because obviously I'm using my CAS to do that. So I have answered part A. Let's go back to the question. Find the mean and standard deviation of the weights of Australian rules footballs. It's done, okay? Question B is basically the same. The lengths of Australian rules footballs are normally distributed. It's found that 92% of the balls have a length greater than 148 centimetres, while 68% have a length less than 164 centimetres. Find the mean and standard deviation of the lengths of Australian rules footballs. I need to point out here, I don't know if this is true. I don't know how long a football is. It doesn't matter. In fact, that sounds ridiculous, 164 centimetres. Maybe that's meant to be millimetres. Yeah, but it still sounds like a lot of variation. It doesn't matter. It's the question. Let's just answer it. So 92% of the balls have a length greater than, I am going to use millimetres now because centimetres is absurd. I need to find the mean and standard deviation. It's exactly the same question with different numbers. So pause it and have a go and then hit play to see how you went. Okay, so you can see there what I've done. First, I've defined my variable as L, which is the length of footballs, and I've written it in millimetres. I did actually go and change it in the question. And I've noted that L is normally distributed with mean and standard deviation unknown. So the probability that L is greater than 148 is 0.92 and the probability L is less than 164 is 0.68. So I rewrote those as Z values. So 148 minus mu over sigma and 164 minus mu over sigma get replaced in those equations. Then I grabbed my CAS. So let's go and have a look at what I did in my CAS. Oh, I don't think you can quite see that. Let's just scroll down. No, that won't work. I'll have to move it up. Just move that up a bit. So the first thing I did there was inverse norm CDF with a right tail, because the first one is greater than, with a probability of 0.92, and it gave me negative 1.4051. And then for the second one, I had a left tail because Z is less than in this case, and my probability was 0.68. That's my probability there, and I got 0.4677. So then I simply put that into simultaneous equations using X for mu and Y for sigma, and I got X is 160, so I wrote that down, 160 millimeters, and I got Y is 8.5435. I rounded that to 1 decimal place. Sigma is 8.5 because I wasn't told how many decimal places, and that seems a reasonable amount for the length of a football, half a millimeter. To the nearest millimeter. To the nearest tenth of a millimeter, I should say. Okay, so that's part A and B. Let's have a look now. I'll just take my CAS away again at part C. Okay, so part C says, assuming that lengths and weights of footballs are independent, find the probability that a randomly selected football has a weight less than 418 grams and a length less than 164 centimeters. So let's look at this. Basically what I'm asked for here, this is part C, is the probability that, now this is why it's really important that I've defined my two variables differently, because in this example, I need to use both of those variables. So that the weight is less than 418 grams, and that's the intersection, the length is less than 164. Okay, but I am told that they are independent. So remember that for independent events, the probability of A intersection B is equal to the probability of A times the probability of B. Now, this is not always true. This is only true if they're independent. If you've got dependents, you need a different rule. So that means that basically I'm looking for the probability that the weight is less than 418 multiplied by the probability that the length is less than 164. So I think it's worth pointing out here that that's the hardest part of this question. Now that I've got this, it's just a case of grabbing my CAS, calculating what this is, and multiplying them together. All right. CAS skills are your base skills. If you don't know how to do things on CAS, that's the first thing to fix. But the second thing here is combining all our probability knowledge, looking at the fact that we're told this is independent. What does that tell me? It tells me this rule. And without that rule, I can't answer this question. Okay, so let's do that. I'm going to pause it. You have a go and do it, and then come back and see if you get what I get. So the first thing I wanted to show you is that I've gone back to my answer to question A in order to do this. I hope you remembered not to do an inverse this time, but to do a norm CDF. And we have our lower boundary is negative infinity and our upper boundary is 425. So if I'm using the W distribution, then I've got a mean of 425 and a standard deviation of 8.3. So I've entered those in. So let's see what CAS gives us. Okay, 0.5. That's interesting. All right. Then that makes it nice and easy. I don't need to worry about rounding. Okay, now I'm going to do the same thing for the other part of the question. Okay, so here's the other part of this problem. For part B, I had L, and this is also normally distributed, and I'm going, because this is also less than, I'm looking at when it's less than 164, so calculating the probability of that using the mean and standard deviation given to me well, not given to me, that I calculated in part B. So I hit OK and I get 0.6810. Okay, so let's go back to where I'm actually solving this question. What I'm going to do is jot those down. So I had 0.5 here and I had 0.681, what was it? 6810, and I'm going to actually do the calculation straight away. So let's do just times, hang on. Oh, I don't have a proper keyboard. I'll just have to do this symbol because I'm on my computer, times 0.5. And I get 0.3405. Okay. So I've answered part C, assuming that the lengths and weights are independent. Find the probability that a randomly selected football weighs less than this amount and has a length less than this amount. All right, one more part to this question. Okay, this last part of the question is a little bit tricky because what we're doing now is we're combining all our knowledge of probability so far. A team is practicing with 10 footballs. Find the probability that at least 2 footballs weigh more than 437 grams. So look at what we've got here. We've got a normally distributed value, which is weight, W, but it is possible to calculate the probability that it is more than 437 grams. In fact, I think the probability that 1 football weighs more than 437 grams was given to me. It was part of my original question. Let's just double check that. Where is that? Yes, there it is. 7.5% weigh more than 437 grams. Okay, so I know that that is 7.5%. I'm just going to jot this down. So the probability that that happens, now let's just say I'm looking for a football that weighs more than 437 grams. And I've got a big basket of footballs and I grab one. I wonder if it's 437 grams or more. I put it on the scales. Maybe it is, maybe it isn't. Does this sound familiar? Yes, success or failure. If it's a success, then the football weighs more than 437 grams. If it's a failure, then it doesn't weigh more than 437 grams. So what I can do is I can actually pull 2 footballs out, and now what I've got is a binomial distribution because I've got a Bernoulli trial, which is where I've got success or failure, and the probability of success is known, and I know how many trials I'm going to do. I'm going to do, I've got 10. I've got 10 footballs which were randomly selected from a huge batch of footballs, okay? So that means that now I have to switch from normal to binomial. So let's look at that. So what I've jotted down there is, first of all, I've defined X as the number of footballs greater than 437 grams. I could have said in a trial of 10. So X is binomial with 10 trials and a probability of success, P, of 0.075. So what I'm looking for then is the probability that X is greater than or equal to 2. It does say at least, so that includes 2. So probability that X is greater than or equal to 2. I'm going to reach for my trusty CAS now. There it is. Just to clear things up, let's get rid of all that. Okay, I'm back now to discrete, and this is greater than or equal to, so it's a binomial CDF. Remember this? My lower bound, it's greater than or equal to 2, so my lower bound is 2. My upper bound is 10 because there are 10 trials. Number of trials is 10. Probability of success, 0.075. Hit OK. Write down the answer. It doesn't say again, so I'll just go to 4 decimal places, 1.696. that's not right. 0.1696. Okay. B is very similar. So again, pause now and see if you can figure out B, and then hit play again to see how you went. Okay, so there's what I've done so far. Did you define a new variable in part B? Let y be the number of footies less than 164. That should say millimeters. Let's put it in. 164 millimeters. The probability that the length is less than 164, we calculated this in the previous question, so I didn't recalculate it. I simply went back, had a look what I had done on the previous page. There it is, 0.6810, because we'd already done this question. Probability of having a length less than 164. So I just took my answer from the previous page there. Therefore, my new variable y is binomial. Number of trials is 10. Probability of success is 0.6810. So what I'm looking for then is the probability that y is greater than or equal to 6, because y is the number of footballs less than this length. Okay, let's have a look at what I did on my CAS. It looks exactly the same as before. My lower bound is 6 because I've got y greater than or equal to 6. My upper bound is 10 because out of 10 trials, that's the most that can happen. The number of trials is 10 and the probability of success is 0.6810. So let's do it. And I get 0.8153. Okay, and we're done. All right, that was pretty long and complicated. It started off pretty straightforward, and most of the questions that you'll see, at least initially, will be like parts A and B. And then parts C and D are those slightly less routine types of questions. But they do go as an example to show you how you really need to be thinking about all aspects. Part D in particular, because especially if you're in the chapter on normal probability, it might throw you. But this can happen in the exam, that you start in a question looking at normal probabilities and then somehow they throw in something that is in fact binomial, and it is connected, right? This is legitimately the way you would calculate these values if you really needed to. Okay, so that's the end of that video, and that's the end of our course. All right, bye.